All right. Looks like we are good to go. Uh, let's give it about another 10 seconds or so here just to make sure let everybody get joined. So if you're joining, welcome. Let's give it a few minutes. All right. All right. We'll go ahead and get started. So welcome appreciate everybody that joined here today. This session is going to be on high density with Matt Schwartz, who's a distinguished engineer at Cisco, and Bill Anderson, who is the CEO of AmpThink. And just by way of a little bit of housekeeping, we do have gift certificates that we're giving away. The gift certificates we're gonna do a question at the end, and then what I'll ask you to do is just send me your answers privately. Send me your answers to the question. I'm not going to tell you what the question is yet. You're gonna have to wait till the end, and then we'll give you the question, and then privately send me your answers. And the first 10 that apply to that or give me the right answers will get a $25 gift certificate to the Cisco store, thanks to the partner ecosystem. And then at the very end, we're going to have Joe Maestri join us, and he's going to talk a little bit about the partner ecosystem. But to get started, like I said, we've got a couple of big names in the high density industry here. So, Bill, welcome. Thanks for joining.
Thank you.
Matt, thanks for joining the session.
Sure thing.
So let's just start off. Bill, how about give us a little bit of background on AmpThink? What is AmpThink? What do you guys do? What's your secret sauce?
So AmpThink is a provider of technical services or technology systems for sports and entertainment venues. We've been in business since 2011, and over the past 14 years, we've participated in projects in 113 stadiums and arenas. Our bread and butter is Wi-Fi. That's where we got started building high density Wi-Fi solutions, and that's where I got to know Matt Schwartz. And over the past decade plus of working together, we've had the opportunity to work in a range of venues on the professional side and all the major leagues. A lot of opportunities in the university space, but basically our company builds the technology that underpins the venues that we all love to attend to watch live sports events. And, our role today is comprehensive, so we're responsible for designing and building the structured cabling infrastructure, the wired and wireless networks that sit on top of it, and then some of the AV systems that are enabled. And all of it is really kind of built around a very specific and kind of intentional process around actually delivering those systems. So we're a little bit different than folks who are in the traditional Cisco resale space. Our focus is more around the construction part of the project. So while we do provide some networking solutions, it's really our time with the customer, getting them from learning about their venue to delivering the system that kind of differentiates our practice. And so in that vein, we do have a network design team that probably would be very familiar to the folks on this call. It's going to be responsible for kind of developing the systems or designing the systems that go into a building. And from there, we really kind of take over and we become a very construction focused. So on the pre-construction side, we've got a large facility in Garland, Texas, and a sister facility in Fort Erie, Ontario, where we actually pre-assemble, build, manufacture, kit, and kind of make all of the pieces that are required to install these systems in these buildings. We have an entire field force that's focused on actually going into the field and supporting construction, working with construction managers to actually assist them with making sure that things are constructed in a timely manner, and in many cases have a large field force involved in those projects. And then ultimately working with talented engineers from Cisco like Matt. In the post-construction phase, we optimize those systems. In fact, what we'll talk about today is really the lessons that we've learned over the past decade trying to make those systems work and supporting those systems and live events for venues, the biggest in the world, like SoFi Stadium, but also smaller venues. Recently, we collaborated on the Kansas City Current, a 12,000 seat women's soccer league stadium, which where we delivered exactly the same quality of infrastructure, but we did it on a smaller scale and with more intent. So our goal is, as AmThink, is to try and understand our customers' needs and then apply the right technology solutions. And a lot of that starts with connectivity, and more as Wi-Fi's capabilities have increased. Wi-Fi is the underpinning source of connectivity that we rely on in the building.
Awesome. So, and now you guys are also doing signage and that sort of stuff too, right? I mean, this is
Yes, sir.
all
So, absolutely. Wi-Fi was where we started. We built into networks. I'm very involved in building compute infrastructure. Had a very productive partnership. I always like to talk about how at SoFi Stadium they gave us 7 racks to power the stadium, and they told us we're going to have 200 servers, and we actually fit everything into 16U. And then we had to manufacture lights to stick in all the empty cabinets because HyperFlex had allowed us
They
to
make great
complete.
coat racks. You can go into SoFi and hang your coat in those racks.
Yeah, absolutely. So, but we've been involved there, and then got very involved in the 2014-2015 period with a bunch of people at Cisco around Cisco Vision, now part of the Wipro family, but still Vision Edge and important signage solutions. So we've built some of the largest signage networks in sports, Allegiant Stadium, SoFi Stadium, things of that like, where we power them digitally. And then from a manufacturing perspective, we build LED scoreboards and spectaculars, and it's a newer part of our business, but part of AV. And importantly, back to this idea of, connectivity being the most important thing that we provide inside of a stadium. The biggest difference between us and the folks that we compete with in this space is that, we're focused on a network-centric approach. We're making sure that all of these systems are IP connected, whether that's your audio system or it's your scoreboard or it's your IPTV system or it's your ticketing system. It's making sure that everything flows over an IP backbone. And Matt and I actually had the opportunity to kind of collaborate on probably what is the largest implementation of its kind that's purely IP based at SoFi Stadium. And I'm going to forget, Matt, how many petabytes? 53.
I think it was 53.
53 petabytes of data that we actually managed to flow over the network in a 24-hour period. So it's what we do in the stadiums is really try and bring everything together and make it work cohesively on a common network. That's really the story we tell.
That's awesome. So, Matt, I'm going to put on the way back hat for a little bit.
Is
Take
it
you
forwards
back
or
in
backwards?
time.
It's kind of backwards. It's got to be
That's
backwards
right.
then.
So tell me a little bit about, I mean, you were kind of there at the very, very beginning, right? 2.4 only, right?
Yeah.
Tell me a little bit about the history of high, we didn't really even call it, I don't think, high density at that point. It was just
Yeah, I mean,
Wi-Fi.
I would start and say that I was there before I even knew I was there because we didn't know. That's probably the key, is that no one, I've said this a bunch of times, no one just, walked into a stadium and knew exactly how everything was going to work. So it started roughly a little before this slide, but this slide is the beginning of like where the evolution started. But prior to this, the Yankee Stadium was being built in 2007, 2008, opened in 2009. Cowboy Stadium was right there, right behind it, also in 2009. Couple interesting things though, the iPhone was pretty new back then too, and AT&T had exclusive rights to it early on, and there was no there was no mystery that they were also a very early adopter of Wi-Fi offload, and ATT Wi-Fi ran on the Whisper protocol, and it's because the people had these very powerful devices in their pockets, and they were going in and just crushing cellular networks. So I rolled into Yankee Stadium, and the design, other people had gone and kind of said, "Oh, Wi-Fi, sure, yeah, let's put all these Omnis everywhere," and then that became the first, like, well, There's a difference between coverage and capacity, right? You can have great coverage. It just won't work, but you can have all the coverage you want.
It seems obvious
And
now,
so,
but
yeah, right. But back then it was like, whoa, wait a second.
yeah.
And then so we started marching into this thing where we're like, we need better antennas. We need these, highly directional antennas that can, so we can create isolation and we can get more cells, and that the APs are nearly as busy because not every single one of them hears every single other one of them. So we went down, and that was in the 2008 to 2012 range. And if you remember, we used to name all of our APs after fish. So, that was the grayling days, was the first stadium specific antenna. Then we moved on to like the Gillaroo. But as we were doing this, we started hitting some challenges, and Bill will jump in here at any point and correct me on the things I've missed. But distance was a key. So we basically started off with specific antennas, but then we realized that we also need some very specific features. So Bill and I worked together on our first Super Bowl at Lucas Oil Stadium in 2012, and I think, keep me honest, Bill, 18 controllers, I believe.
Yeah, and at 25 actually, 25
Okay.
controllers, and we managed to get the system working, and we actually, I think, did a really good job of giving some capacity to the network that we knew that we needed to deliver, but it was also kind of really informative, because what we figured out is, in spite of our best efforts, we didn't get the signal everywhere where it needed to be, and probably the biggest lesson was that we underserved the premium seats, right? So the guy shows up at the Super Bowl, and the guys in the nosebleeds have great coverage, and the guy in the back of the section,
They're so close to an AP.
they're screaming and they're happy, but the guy who spent $8,000 to sit at the 50-yard line, and he's in row 2, he's like, yeah, I don't know what you're talking about. There's no Wi-Fi here. And he had an iPhone, and he had all the capabilities, but we definitely didn't have it solved, and the feature set wasn't there, as Matt was alluding to. We had 25 controllers because we needed to take and group the APs into controllers, because the controller determined the feature set of the access point, and you didn't have the ability to create groups and separate stuff. So our solution was, well, we'll stack 25 boxes together, and we'll cable them in, and then Matt will do this magic where he puts the right APs on the right controller, and
Give a lot of credit to Josh on that one.
yeah. And
Yeah,
there was a tremendous amount of late night silliness with trying to figure out, first of all, where even to put 25 controllers in the data center, and then how to get them connected in. So a very different time. It was, all kind of new to all of us. We were just kind of feeling our way through it.
And that was the birth of RF profiles.
Yeah.
They came out of that. Some other things, we came out with, multicast specific data rates. We came out with a CCA knob. We came out with, probably the biggest one was the receive started packet threshold. RxSOP came out of this era, where we knew that, these APs are super busy, but they're hearing things that are so far away that, like, we know that this AP doesn't need to talk to that client that's that far away. There's another AP over there. And so a lot of that stuff was coming through this era. And then eventually we kept moving on. And with those knobs, specific data rates depending on which group the AP was in, because obviously in the bowl, you're going to have, a set of RF configurations that's going to be hopefully very different than in a suite or in a club or something like that. So as we kept moving, when you turn those knobs like RxSOP, it doesn't really discriminate. It's a pretty hard wall. And so when you try to quiet down how much the AP is hearing from far away, you're also shortening the distance. And that became the next big kind of like hurdle. And that brings us up to the proximate part of the slide. So then,
Yeah, that was really Matt
okay.
Life. It was working with Matt, and Jake Fussell was the engineer who was the one who really had to own it. And he said, okay, well, now the problem, the solution is we've been able to, as Matt would tell you at the time, put the earmuffs on the AP and make it listen better and make it more productive. But the problem is at the front of the section, the place that we already knew we had some difficulty, and we were putting some antennas down there. Now the problem had moved to the middle of the section. And we knew that we had to get the APs closer to people, and we started to try and come up with approaches. And at MetLife, we installed some of the first handrails that were installed in the world, and we put antennas in them, and we worked through all of the physical construction parts, but more importantly, we worked through a lot of regulatory elements. So there's a lot of work done by Cisco on the back end to figure out if we could put antennas that close to people and whether or not we were going to get in trouble and if we were going to, cause cancer and all this kind of craziness. And we worked through that for a couple of years. And, ultimately, the real problem with handrails was that in very wide sections, particularly as we got into colleges, it fell apart one more time. And it got to where the sections were so wide that the handrails were too far apart and created too much noise. And we settled into this idea that given the tool set we had, the best way to solve the problem was to put an AP underneath the seat. And there was some pioneering work done by one of Cisco's competitors on the West Coast, and between Chuck Lukashevsky, who was the gentleman leading that effort, and Matt, who was leading the counter effort from a Cisco perspective, we implemented some very, very large underseat networks, venues with 100,000 plus seats. And we started to kind of find our ground. We started to find a way between the features that Cisco had been able to deliver and building construction methodology that allowed us to get the APs really close to the end user to build performance systems. And with the limited spectrum we had, we started to actually get large amounts of people. In fact, in the very early days of SoFi, we didn't have a DAS, and we were connecting 50 or 60,000 people concurrently, and it actually worked. And it was a pretty phenomenal experience. It was an important evolution of the feature set.
Interesting.
And I will add in one thing. So, I mean, and we don't have to, Chuck was with Aruba at the time. But I remember during this era, somebody came to me, and if you've ever been to Josh and I's Cisco Live presentation, we talk about, the 3 RF relationships, and every single year we're like, should we get rid of this? And then we were like, nah, we can't because it's still important. But they some other folks had gone and put APs underneath the concrete, not underneath the seat. But here's the thing. Because like I said, no one woke up that morning and knew exactly how to do it. But if you only looked at the 1 RF relationship, which is how does the client see that AP, which is your site survey, it actually looked pretty good, right? You had these nice little small cells up there. But what you weren't thinking about was, are you making it back through the concrete? And all of those APs that are sitting in that cavity underneath the concrete all hear each other like really, really badly. So it didn't take off, and then they moved it up above the concrete, and then that's still got its place today. But we've evolved even since then. So we'll keep moving along this thing. And so we went through, antennas, then we went to features, then we went to proximate, got to get closer because our features were kind of hurting us a little bit. But at the time, we didn't know exactly. We hadn't nailed exactly what was hurting us the most. We just knew that we had knobs that could get us past it, and that we could fill in with these other kind of arrangements. But then more recently, we went, and this is what's being called, like hyper-directional. We went back to the antenna, and we were like, all right, we've done all these other things, but there's something still missing. And at least in my opinion, we did a couple things when we went to like the 9104, which was the first iteration. And we fixed a couple things there. One was, it was very difficult, especially like in an arena and in some of the larger stadiums where depending on the distance, you needed, a different antenna. And that was super challenging for people that didn't know this that well. You'd be like, well, wait a second, you need the wide antenna there, and you need the narrow one here, and you need this other one here. So we came in with all of our beam switching technology, which allowed us to basically use the same product in various different configurations, so we could match different distances with the beam width that we needed. Then we also added in beam steering, but what we did the most was we started really looking at the side lobes of the antennas, and that was what was critical. And what we figured out was we were turning those knobs to the extent that we had to, because even though the AP was really directional, there was some pretty decent side lobes. So the east-west kind of contention was still there. And so when you're turning that knob, that's actually what drove, the proximate revolution. Was we weren't getting there from a distance perspective. So we went and we did a lot of work on our filtering and things like that to basically suppress our side lobes substantially and get a lot more distance out of it.
And I think there's a great story because we had talked about this, and Matt had taken a team and they had gone to a Claire Brothers facility. They have this beautiful kind of facility to test concerts and this
Rock
really high
lidditz.
ceiling
Yeah.
rock lidditz. And Matt took a team up there and he and I were on the phone and he was testing these filters. And I was asking about, did it work? And then he was joking that, well, it didn't work. And then he came in and he said, well, actually it did work. It worked so well that we were able to take and put tape down on the floor, and we were able to actually, from an RF perspective, paint inside the line, so to speak. And that was really transformative. It was this moment where the filters provided this level of RF control. It wasn't just that we projected or that the device projected the signal 200 feet or 170 feet. It was that it did it in a way that was controlled, and that the control would allow us ultimately to take and deliver deployments that were really structured in a way to make them performant and give us the ability to move beyond kind of the constraints or limitations of the underseat approach.
Nice.
Gotta give credit to Fred Anderson on that one. When we were in that building, he was a mad scientist. He's since retired from Cisco, but one of the best minds. And he had these little yellow, like little things that you would almost see like at a crime scene where they're identifying objects on the ground. But I didn't mean it to sound like a crime scene, but you know what I mean? Like those little yellow
Yeah.
placard things. And he
Yeah.
had them placed around the floor of the facility. And he had done all of these, calculations. He's scribbling in his notebook, and he's like, over there, we should see this, and we'd go over there and I'd be like, wow, Fred, you're spot on.
Yeah.
And so like, I guess the real moral of the story is I don't know if other, people are spending this much time figuring it out, but we spent a bunch of time figuring it
Yeah.
out.
Yeah.
Well, and I think the important thing is the results were really pretty spectacular. When I was not with Matt in 2011 at AT&T Stadium, but I was with him in 2012 at Lucas Oil Stadium, and the moment when we got to the end of the Super Bowl and we had done 300 gigs of traffic, we were ecstatic. We just thought we had hung the moon, and then a year later, we tripled that number, and we were in New Orleans at the Superdome and we did a terabyte, and I can remember we were fist bumps, and there was huge celebrations, and we went out and we partied like we were rock stars. But I don't think any of us could have predicted really what we accomplished over time. The evolution of product and construction methodology and kind of the hard work of doing it and having success and having failure, drove the growth of Wi-Fi to where by the time we got to Allegiant Stadium, 34 terabytes, and we were on pace to continue to really grow it. And when you look at Allegiant Stadium and you look at that 34 terabyte number, which improves 3 terabytes beyond what was at SoFi or State Farm, that really came down to the capabilities or the functionality of this overhead approach, right? It was the next cap, and over this chart that I've thrown up there, if you look at each of these moments, there was some kind of innovation. In the case of Lucas Oil Stadium, it was a packaged antenna. When you get to Levi Stadium, it's truly under seat. By the time you've kind of pushed out to SoFi Stadium, now you've got Wi-Fi 6, and you've got this new way to modulate and control the signal. And then with Allegiant Stadium, you've got 4th generation stadium technology, and it had us pointed in an incredible direction. Now, last year we took a little bit of a step back as an industry. A lot of contention over that particular event, and there's some activity on the part of the cellular providers to redirect traffic away from the Wi-Fi network and to direct it specifically to their cellular DAS systems to prove the robustness of DAS. But ultimately, Matt and I are of the opinion that, in the absence of the kind of intervention of the carriers, we were pointed at 40 plus terabytes of data. And it's just kind of staggering to look back over that period and realize, the evolution, and then not just that there was evolution and then we changed technology, but the technology had a real impact. And what do I mean by that? That we changed the way fans experience live sports. If you go back to Lucas Oil Stadium, you might have been posting on Facebook. by the time you get to Allegiant Stadium, you're live streaming from the event, right? And there's some big impactful moments for me over the course of those years where we went from being recording fan journeys to becoming a content creation engine. I can remember at US Bank Stadium, the first time not there was a game played, but the first time there was a major concert, it was Metallica. And we watched everybody turn their phone around, and we watched 10,000 people try to live stream Metallica, right? And it was a mind-blowing experience because you realize that the journey around connectivity wasn't just us moving more traffic, it was us creating new ways to experience a live event. And I think that's probably for me the most impactful part is we talk about Wi-Fi and we talk about it like as engineers, but we don't understand the real connectivity to the human experience. And it's super, super crazy what we've accomplished in a decade.
Yeah.
I would add on one thing. I think towards the end of this graphic, like things did. I think the State Farm year, man, we were barreling towards 40 that year. There was an issue in the wired network, and so I always want to make sure that that's pretty clear. Like it wasn't a Wi-Fi issue at all. There was definitely a scaling issue on the wired network. I was in that room. It was pretty tense, and but I mean, and there was reasons it certainly could have been avoided. And sometimes it just depends on the network design and who's involved and things like that. So, but then the next year at Allegiant, it pulled back a bit because that's where even ahead of what happened, what Bill just described at Caesars. But that's where you first started to see them steering, some of the providers steering towards 5G. And that's still pre 6 gigahertz, right? So 6 gigahertz, I think, is a different beast now. I think we're gonna see this chart get back on track at Levi's this year because 6 gigahertz, now that we've got, and we'll talk later in this presentation on the latest greatest technology, but we're seeing tremendous adoption across 6 gigahertz, and we've run pilots at Bottle Rock and at the US Open and things like that, where the place is packed and we're still screaming, 300-400 megs through the network. So I think that the radio interface being like the bottleneck isn't going to be the case if you have a really robust 6 gig network.
Well, I think it comes back to what Bill said originally. It's about the fan experience, right? The fans don't really care how that data gets out, right? Or comes in, right? And so
there's one point there that it's not on the slide, but Bill and I were talking about it this morning. We had this opportunity several years back where the Kansas City Royals were in back-to-back World Series, and the actual network changed very, very little, like minimal changes. And World Series are just like Super Bowls. There's no empty seats, right? Like the place is packed. So the network's essentially 98% the same, 99% the same, but the amount of data that was offloaded onto the Wi-Fi network almost doubled in 1 year. So that just tells you everything you need to know right there. You see what I mean? Like the amount of apps that are out there now that are consuming data, the ways that people are interacting with their friends and family that aren't there. We always call it vanity events. Everyone's like, look at me, you're not here. And you're sending pictures and video to people. So it takes up a lot of network resources.
For sure. Hey, real quick, just if you have any questions for Bill or Matt, just throw them in the chat window and we'll try to get to them if we can as we go along. So feel free to throw your questions in there. And go ahead and you can just do a reply to all for those questions so that one of us will see them. So, okay. All right. So this kind of gives us the numbers over time. Where are we going to now? Where are we headed to? Economics.
I mean, I think, kind of moved ahead in the deck. I think the most interesting thing from our perspective is that Wi-Fi has an incredibly compelling financial story. So we talked a little bit about how the carriers are trying to take and move traffic over to the 5G network to prove the robustness of that infrastructure, and it is very robust, and to demonstrate the capabilities of their networks and to prove out why you would spend money on a subscription. But I think the thing that's fascinating to us is the actual unit economics that underpin it, right? There are a lot more Wi-Fi devices than there are cellular devices, and the chipsets are less expensive, and there's less intellectual property that is patented and protected in the Wi-Fi space because companies like Cisco have freely contributed their intellectual property to the world standard. When we saw the investment that was made at SoFi Stadium and compared it to the investment we made in the Wi-Fi network at SoFi Stadium and realized, hey, this is infrastructure that's 105 times less expensive. And then on a go forward basis, you looked at this consolidated radio footprint, all the spectrums neatly packaged, setting aside 2.4, but neatly packaged between 5 and 7 gigahertz. And therefore you could build less complex radio architectures to kind of address that band versus the cellular providers who start at 600 megahertz and move all the way up to 35 gigahertz and have to address these disparate physical radio layers. We think the interesting part is that Wi-Fi is going to be the least expensive way to get people robustly connected, and whether it's Wi-Fi 7 that introduce additional robustness or Wi-Fi 8 that will introduce more stability into the systems, when you look up and realize that your cheapest price per bit is going to be Wi-Fi, we think the future for Wi-Fi in public venues, particularly smaller public venues that can't get a third party to invest millions of dollars in their building, we think that that's going to be the connectivity solution on a go-forward basis. And if you look at mobility, meaning the ability to easily transition between a licensed network and an unlicensed network using whether the technology is pass-pointing towards Cisco's open roaming standards or so on, I think that opportunity in sports means that Wi-Fi will have an increasing level of importance to operations and building, and we'll start to be able to use the spectrum because we have so much more differently to provide quality of service enhancements that weren't possible previously. So we see kind of a golden era for Wi-Fi and public venues ahead of us, and we see a very stable platform again with Wi-Fi 6E, 7 to take and support that.
Anything else you want to say about the pricing or anything like that on the cost? Matt, are you?
I think the interesting part maybe
no.
for one of the things to note though is
It's
that as the access points have kind of evolved, if you adjust it for inflation, the price of the access points have actually gone down. Maybe that's the one really interesting part, right? And so again, I think it's just there's the economics support Wi-Fi on a go forward basis.
I can say that, probably not stadium specific. Actually, it's definitely not stadium specific, but some of the larger providers have sat down and told us that, like, their investment in DAS in, non-stadium buildings is actually going down substantially because it's so much cheaper to install a robust Wi-Fi network and have Wi-Fi calling in a lot of these places. And then if you look at like other industries, like we do a fair amount of work in the cruise line industry. There's a whole lot of Wi-Fi out there on those ships. And these more recent ships, I mean, they're all high density networks in their own right. Some of them have, the latest one that I'm aware of has almost 5,000 APs on it, which is more than all of these stadiums, right? But if you look at what's happening on those vessels, I mean, I can make a phone call or a FaceTime just the same as I can at home. It's pretty impressive.
Well,
I think there's still some gaps, right? We've still got to solve some of the constructability issues, and I think that's the other piece is just you're going to see, or we hope to see, because you guys have to do the work, Cisco has to do the heavy lifting, the investment in the technology that makes it easier and more cost effective to install. Because that's still a gap, right? Construction is still a really, really big part of the experience.
What drives that? I mean, we talked about the different overhead, under seat. When you see a venue like that, what typically drives up costs for Wi-Fi?
believe it or not, has nothing to do with technology. It's concrete and steel, pathway and cabling. It's if you got to figure out how to put, a couple thousand holes in seats, and the seats have a 4-inch thick piece of concrete underneath them, and you got to drill a hole through it. And then you have to weatherize it. In an outdoor stadium, the worst thing you can do in the world is put a hole in the stadium and have it fill up with water, and then have the water pour into somebody's multi-million-dollar club where they're serving a buffet dinner.
That gets expensive real quick.
It's very expensive. It has real kind of consequences for the building operator and the building owner. It's that piece, and then it's coupled with the fact that way we got to where we are is by actually building networks around full venues. And as we've had to take and figure out how to deal with venues that aren't full, we still haven't really kind of solved that problem until we really developed, or until the Cisco team and others in the industry developed the idea of a hyperdirectional antenna, right? This ability to kind of reduce what we're spending, and that's really the next big wave for us.
I love that term, hyperdirectional antennas.
Yeah, we love that term too.
Is that a Bill Anderson term?
There might have been some involvement on our part in putting a name to it, and
Nice.
But we're excited about technology. I think what's interesting is hyperdirectional technology is of course we're very specifically talking about the Cisco portfolio, but it's a more general movement in the industry, licensed and unlicensed, to kind of come up with solutions that are more constructible, easier to operate, easier to maintain, and importantly, perform better when the building isn't full, because underseat still has some real limitations when it comes to the performance. And Matt can talk to that maybe for a minute, and then I can talk a little bit about some of the economics.
Okay.
Sure. So this particular slide, if you've seen my presentations, this is in most of them, but this was a big learning moment as well, because I feel like the industry might have over-rotated a little bit towards underseat, where you were seeing a lot of, and now keep in mind the latest generation of directional antennas hadn't been born yet, but still there were a couple, or probably more than a couple, designs that I was seeing back during this era, where I was like, wow, you have these really amazing overhead mounting assets, but you're still choosing to just put everything underneath the seat. And then that kind of reared its head after a while, because Wi-Fi being the way that it is, and just like it took us all the way back to like 2007, 2008 at the Yankees, right? Like, just because it's under a seat doesn't mean it doesn't hear everything. So what happens is for it to perform optimally, you need to have a body in all those seats. You need to have that absorption to knock down that signal. So on the left-hand side, this is an all under seat deployment. Down the left-hand side of that, those are all access points. Along the top of that axis is time. And you can see how red and that's basically just showing, channel utilization and contention. So just crazy busy when the place is empty.
Yeah.
And then time of the event, you can see where it actually got pretty good, and that was the Super Bowl. So there was no
bodies
empty
absorbing
seats.
the energy, I guess. Right?
Yep, exactly. There's no empty seats whatsoever in that place. And in fact, during the Super Bowl, there's several thousand extra people there, press and media and all these things that wouldn't normally be at an event like that. And so you'll start to see things. I've told this story a lot, but for anyone that hasn't heard it, you'll start to see weird things where you'll walk around with like an air check or whatever analyzer you might be using, and it'll say non-Wi-Fi interfere on channel 149, whatever, pick a channel. And so, we got there and the NFL's like, hey, we got to find these non-Wi-Fi interferers. So we start looking, because a lot of times you will find something. But in the bowl, I knew something was up, because I was like, it kept seeming to move around. It'd be a different channel. And then as soon as you would go into a vomitory and maybe head out towards the concourse, gone. I was like, wait a second. So we did a quick test, because I basically came around to the idea that I thought it was Wi-Fi. I was like, I think it's Wi-Fi. And so we would see a channel, we'd remove that channel from the DCA list, and it would go away. So we proved the point that what it is in scenarios like that, when you have under seat and it's all under seat and there's that much Wi-Fi in the air, your analyzer might be hearing some transmission from clear across the stadium where it recognizes the energy on the channel, but it cannot decode the header. So it doesn't know that it's Wi-Fi. It's basically garbled, junky Wi-Fi. And that phenomena happens. So where we're going with this is a lot of these big venues, they're not packed every single event. They might have a concert where behind the stage, there's no one in those seats, right? That's where the stage is, and it's all blacked out behind there. They might have motocross, monster trucks, you name it. Where maybe sometimes the entire upper bowl is just black curtains, and they only sell the lower bowl. So the Wi-Fi kind of beats you up on that. So when you go to the right-hand side, that's all directional, and you can see it's really, really quiet when it's empty
Yeah.
comparatively, and then it heats up when it's full, but it's also a lot less APs. So bringing that forward to today, we're not saying that one or the other is necessarily all right. We're saying that in most of the large stadiums, the big NFL stadiums, it's a hybrid. It's going to be both. It's going to be directional, hyper-directional, everywhere that it makes sense that you can do that, and then under seat everywhere that it doesn't. And I'll let Bill chime in on this. I'll tee him up for this one. It's my opinion, and I didn't discuss this with Bill earlier, so it'd be great to see what his answer is. It is my opinion that the handrails are a dying breed, and that the only handrails that you'll see are the existing ones, where it makes sense to keep that investment that you've put into getting conduit and enclosures and all these things onto these handrails. It kind of makes sense to keep going with it if you can, but on a new build, I don't see handrails as a viable option anymore.
Yeah, I don't think we disagree. They had a place in time, and their handrails are actually a pretty good methodology in some college configurations, particularly older buildings where under seats just super hard to construct, right? And we've had some success there. But ultimately, overhead first and then infill with under seat. And that's the pattern that we're carrying forward in the new NFL builds, is where you can get the overhead asset to it and then augment with under seat. But when we can be purely overhead, we're trying to get there because we're finding that, set aside the technical advantages of the overhead approach, under seat has some really significant consequences. This is a study we did this year. We looked at really what does underseat cost, and it was interesting because I think our thought was that the biggest difference would be construction, and there really was a difference in construction, but it wasn't a massive difference in construction. Overhead was just a little bit less expensive from a costing perspective, about 16%. This is looking at an NFL building, but what shocked us were the other two statistics, right? When we looked at the 5-year view of a venue that had some kind of temporary seating. So in an NFL building or an arena, you had a retractable seating, and you had to look at what it took to put an access point out and then disconnect it and put it out and disconnect it, and then to clean around the device, and you added it up over 5 years. There was this massive staffing cost that we hadn't contemplated, and that had a real impact on our customers' operational expenses. And by moving into the catwalk or overhead, we essentially eliminated that cost. And then maybe the more important thing was we really started to look at what we were doing on the playing surface. And this may not necessarily kind of be a thing people think about, but in the arena space in particular, teams or venues, sorry, do not make their money based on the sports teams in their building. The sports team is how they pay the rent. It's kind of how they cover their basic infrastructure costs, but they really make their money on concerts. And when you look at a concert, the bulk of their revenue comes from the people who bought a floor seat, a ticket on the floor. And in an underseat environment, we essentially left those people uncovered. Right? Or we told the venue operator, put a temporary network in that's going to cost you a whole bunch of money to put out, and people are going to spill beer on and kick and beat up and figure that out. And once we got to overhead and we could start to provide compelling coverage of that playing service, we're changing the economics. More F&B revenue, happier fans, like the most important part of your people or part of your customer base is getting better service. And so from that perspective, it's not that underseat doesn't work. It's not that, we can't kind of carry it forward or that there aren't better technical solutions. It's the economics of underseat are limited. And what we're doing with overhead deployments now is making a business impact for the people we work with.
Excellent. So I'm going to take because I think we're going to transition here and talk a little bit more about the 9179. We've got a number of questions that are sort of stacking up. So we're going to do this rapid fire because we are running short on time. So I don't want to spend a lot of time. I'm sure there'll be detailed answers, but we'll just kind of go for the quick answer. First question is, how do we deal with low transmit power on clients when using ceiling mounted APs in a stadium? Is there anything unique there with ceiling mounted
Well,
APs?
I think the most important part is to understand that the antenna technology is also better on the receive side of the chain.
Right.
So even though that the client itself is transmitting at lower power, the antenna on the access point is infinitely better, 10 years later at decoding that packet. And so that kind of legacy approach, which is, hey, this near far argument kind of goes away because it all got solved on the access point side.
Especially with line of sight, which hyperdirectional is driving. I would add on to that answer that for both the 9104 and the 9179, we took all the popular, iPhone, Samsung, Google Pixel, all the popular clients out there. We took them outdoors and we did a 200-foot test. And when we did that 200-foot test, we're looking at everything. We're looking at all the RF relationships. How does that client hear the AP? How does that AP hear the client? All those things. And you'd be shocked. And the rest of it's all to Bill's point that the antenna technology's come a long way.
Yeah.
So
in antennas, I think we call it reciprocal, right?
Yep.
So reciprocal gain. So another quick question. This should be a fairly quick one. Do you use mesh?
No.
Okay.
I'll give you a short answer why. In these environments, you don't want to give up any spectrum for backhaul. You want all of it for yourself. So everything, if you're going through and investing in a network like this, every one of these APs has a cable.
Yeah. Okay. Real quick. APs are getting better. Antennas are getting better. Do you see any innovations coming up on wireless network design and layout? On what products to use and where. So really anything significantly changing in how we use APs, antennas in the future.
I'll give a quick answer on that, and then Bill can jump in if he has anything additional. I will say that, we as a company partner very closely with the predominant planning software providers out there, whether it be Ekahau, Hamina, those guys. And I do think that what they have been doing now, like that's not a Cisco specific thing, but what they have been doing has been, they've been putting a lot more functionality into their predictions and how things are working. So I really give them a lot of credit for the effort that they've been doing. What we do is we provide them with all the information they need about our products and how to program that into their software.
I think the most important thing is we're changing how we physically construct these networks, how we mount devices, and our focus on things like adjustability or tiltability and how we tilt things and how to make that more progressive.
So we've got a couple of questions here. One is anything we're doing to manage load balancing between 5 and 6 gigahertz. And then with Wi-Fi 7, do we see MLO as being kind of a critical component? How do we envision MLO?
I'll do the MLO one first because it's easy.
Okay.
Right now, I don't see MLO as being very critical, mainly because the predominant device, at least in North America, is the iPhone, and the iPhone can only do MLO with the 2.4 radio and the 5, or the 2.4 radio and the 6. And I'll knock out another bird because I see a 2.4 question in there somewhere.
Yeah.
We're not advertising 2.4 on the fan-facing networks. Now, do I think the 2.4 is going away completely? No. I think that 2.4 can still be very usable for some low bandwidth things. It just wouldn't be anything fan-facing. But
we use 2.4 extensively for IoT applications now.
Yeah, exactly. So things like that where low bandwidth demand just needs some reliable connectivity. Yeah, sure. Use 2.4.
All right. I'm going to cut off the questions at this point. If we get time at the end, we'll throw a few more in there because I want to get back on track make sure we have time to talk about the 9179 here. So.
All right, let's talk about it. Next slide. So basically, this is our follow-on to the 9104. We set out to do a couple specific things. One of them, and this one I'll give another nod to my good friend Fred Anderson. I was super frustrated with the indoor-outdoor rules of 6 gigahertz, and it's got to have this label that says indoor use only. And if it's going to be outdoors, it has to be standard power only. And it can't be weatherized. And anyway, we came up with this very unique thing called an environment pack. And on that environment pack, there's a little chip that authenticates itself to the AP and weatherizes it. So the one on the right is the outdoor environment pack. And you would go in and you would basically weatherize that entire cavity that's in the back. It replaces the label with the outdoor label, all these things. But now it is standard power only, and that can be used outdoors. On the left is how we ship it by default, which is with the indoor environment pack. That
Super
can
important, by the
be
way, is
LPI.
separate part number. Make sure you order it, because if you forget to order it, you're probably
Good
not going
point.
to get it.
That's a good point.
So sounds like Bill experienced that. But the outdoor environment pack is a separate orderable part. But what makes this key is now with the same product, you can be indoors or outdoors for one, but for two, you don't have to give up the LPI channels if you're indoors. And we know that line of sight at say 100 feet works fine, works well
Yeah.
with LPI power. And so I don't want to give away that spectrum. And so this is the only device on the market, at least as of now. The FCC looked at us like we had three eyes at first, and then they came back around later and said that's a really innovative idea, and they approved this request we had, and we filed the patent way ahead of that just to make sure, and sure enough, it worked out.
It's so critical because I mean, you remember our the first we initially 6 gigahertz when it came out, we were like, oh yeah, we'll put it in standard power and take it outdoors. It's like we were all like, yeah, no problem. And then the regulatory folks said,
Yeah,
not going to happen because it can do low power.
yeah,
So no goes
and
outdoors.
That's something that we should take 30 or 45 seconds and clear up right now because it comes up all the time.
Yeah.
It came up as recently as last week. If it is a composite device, meaning it can do low power indoor or standard power, it is still an indoor device. So if you think that you want to put it in an enclosure and say, well, I'm just going to run it in standard power, technically, according to the rules of the FCC, that is not allowed today. Now, there are some things going on in the background. Extreme went and got a waiver. We looked at that waiver. We don't really want to do that particular waiver. It's way too restrictive in our opinion. We have way more verticals where we would want to protect an AP. And so to only have it be in a sporting event or sporting facility with 12,000 or more people just doesn't make sense for our direction. But there are things like that going on. And then there are some newer things where the FCC is starting to relax some of these rules. So another quick example, we're doing a lot of work right now with the cruise line industry. You're not allowed to have 6 gigahertz on cruise ships. You might in the future. It's being actively discussed because it just doesn't make sense to not allow it there.
Yeah, I just think that's super important with this.
Yep. So another big thing that we wanted to do in the 9179 was previous to even the 9104, we lost the capability of having antennas going in different directions. So like if you remember the 9130, you could do it, the 3802P, you could do it, where you could have either RP TNCs and then a DART or an 8-port DART breakout. And you could have, say, maybe a Gillaroo going one direction and a patch going in the other. We wanted to bring that back because we felt it was valuable in a lot of these bigger stadiums with large overhangs. So we came up with this little small antenna called the Sardine. And basically what you do is it's a configuration option. You can switch your 5 gig low and your 2.4 to the back end connectors. The reason we did it that way is because we expect that whatever you're covering behind you is not going to be long throw. It's going to be something short, like a pocket behind you. So when people ask, well, how come you didn't do 6 gig? Well, we want 6 gig out the front where there's going to be a lot more people. How come you didn't do 5 high? Well, we want that power out the front. So, it was very purposely done. It's a really small antenna. It doesn't require a separate mount. It can be articulated. And then, without having another mount, which was another design kind of decision. So hats off to our antenna and mechanical folks for figuring out a way to not have to mount another thing. And then there will be antenna support for other types of antennas that you could put on there. But this particular antenna is basically super easy to use and does the job for what we intended it to.
Awesome.
And then this is called our Quick Connect. So if you are going to do the external or the outdoor environment pack, you probably are going to want to get this quick connect. This was one of the things I freely admit oversights, and this was probably the one oversight of the brilliant idea of the environment pack, which was, and it hit me immediately at the very first beta site. I was like, looking up, thinking to myself, going, the cable's up there, 100 feet in the air. So now this guy has to get in this lift and go up there and plug this in and seal this thing perfectly and put this door on, all up there on that lift moving around. And within, I think, 2 weeks, we had flooded out a couple of our beta units because we get a lot of rain in Tampa and they weren't sealed correctly. And so basically, this quick connect, it's not a novel thing. We had it for other products in the past, but this allows you to, in a safe manner, down on the ground, install this little quick connect, put the door on properly, seal it with all the dielectric grease, make sure it's properly sealed. And then the secondary thing is we work with a lot of folks that do temporary events, golf, concerts, things like that. And they're putting networks up and taking them down, putting them up and taking them down. I mean, we have a bunch of these at a golf tournament this weekend, right? So the idea that you would have to take that door on or that pack on and off every single time to get your cable back didn't make sense. So make sure you're aware of the quick connect. And then a couple key things to know. I mean, we still test out to 200 feet. We're not saying that we think it's a great idea. Obviously, it's a big sell. But to answer the question from earlier, we know that it works at that distance. But you can get a lot further than before very effectively. It's an integrated unit, doesn't require an enclosure, can be used indoors or outdoors, has a lot of flexibility between narrow, wide, front and back. And then that environment pack is probably it's probably the coolest patent that I've seen in a while in terms of making it easier to deploy robust Wi-Fi in these types of environments.
Awesome. Well, this is a great session. I wished that we had another 10 or 15 minutes because I know these guys have some great stories. I've heard a few of them. And so things like SEAL team extractions for bars or something. No, anyway.
Ooh, that was a really good one. That was Bill's team. Bill has got a team of people that care about him deeply. I looked over and he was gone, but his drink was still there.
Sometimes your liver needs to be protected.
So no, it's so great to have you guys, Bill, Matt. Thanks a ton for your time. I really appreciate you guys taking time out of your busy schedules to share this with the listeners here today. So thanks a bunch. With that, I'm going to ask the question real quick and so now actually don't send it to me. Send it you can just send it to all. We'll just look at all. So you can just broadcast out the answer. The question is, if you want to get a $25 gift certificate to the Cisco store, is can the 9179F be used indoor, outdoor, or both? So it's a multiple choice, A, B, or C, indoors, outdoors, or both. You can just put down indoor, outdoor, or both, whatever your answer is. The first 10 that get it right will get a $25 gift certificate. With that, I'm going to turn it over to Joe Maestri. Joe is part of our partner community. These are the guys that sponsor this event on a monthly basis. So, Joe, I appreciate your sponsorship for this, and I'm going to turn over to you for a little bit.
Of course. Awesome. Thank you so much, everybody, for hopping on. And, Matt, Bill, that was incredible. I learned so much about everything. This is great. So I know
I still want to learn how to put logos on the wall behind me.
The paint is still setting in. But no, thank you so much. And I know we only have 2 minutes. I want to be mindful of everyone's time here. So as Bill and Matt both mentioned, customers and fans no longer buy products, right? But rather they buy experiences. And everything we really talked about today comes down to one thing, and that's refining the customer and fan experience, and even the stadiums as well, right? So that's exactly what our customers are asking for. And when we're talking about high density Wi-Fi and our strong partnership with AmpThink, that's really the foundation for what I'm about to talk about here. So as far as why I'm on this call today, well, I'm here to obviously shout out our partnership with AmpThink, in addition to the rest of our partnerships that we have on the Cisco Meraki enterprise networking marketplace. And really, what we can do here is address any business outcome, any use case Trust me, myself and our team has heard it all, and the folks on this call today have also solved for many of these use cases, business outcomes. And at the risk of sounding like an influencer, feel free to scan the QR code on the screen today to check out our marketplace. And really what we have there is 200 plus partners, including AmpThink, to drive business outcomes and solve unique use cases. We have 350 plus apps that are already plug and play to address pretty much everything and anything. 50 different solution categories across all lines of businesses, and really exclusive integrations built on Cisco APIs. So all of this to really say is we're here to use the foundation of your network, regardless if they're stadiums, concert venues, whatever that might look like, to really turn your dreams into realities by solving for those unique business outcomes and use cases. And all of this with maybe 5 seconds to spare here. Again, scan that QR code to join into all of our subsequent webinars. We'd love to have you. So really appreciate y'all for hopping on.
Thanks again, everyone.
Thank you, everyone.
You